The world's smartest kid just revealed that CERN has opened a portal to the 63rd dimension. Many people might not value the opinions of children on complex issues. Yet, what if a child had insights into the universe that surpassed most adults? While adults often dismiss the capabilities of young minds, history shows us that some of the most profound thinkers were quite young. What if he is right, and we've unwittingly stepped into a shadowy new reality without even realizing it? Join us as we explore these mind-bending concepts. Could the next big revelation about our universe come from a child's imagination? Max Laughlin's scientific adventures. Laughlin, born on November 14, 2002, in San Francisco, California, is a young American who became interested in science and technology at an early age. As a teenager, he caught the attention of the media for inventing a device he called the harvester. He created this gadget using regular household items for less than $15. It's said to gather energy from radio waves, inspired by the ideas of Nikola Tesla. However, there has been some debate about whether this device actually works as claimed. Just as Max was preparing to demonstrate the harvester at a major science conference, an unexpected lawsuit threatened to derail everything. A giant tech company claimed his invention infringed on several of their patents, casting a shadow over his future and the potential of his groundbreaking device. He didn't stop there. He got involved in various events, like speaking at the Nexus Global Youth Summit. He even joined in panel discussions at the World Science Festival in Brisbane. By the time he was 14, he was already taking online courses at MIT. Beyond his inventions, he has also made appearances in media and given public talks, where he shares his ideas and creations. Max's ideas about the Large Hadron Collider and what it might have done have made many people stop and think. Could this giant machine, used by scientists to study tiny particles, have actually opened a door to another world? He seems to think so, and his theories are catching attention because they push us to think beyond what we currently know. But within this incredible universe, one of the smartest young people on the planet has shared his thoughts on CERN and the tools scientists use there to explore these unknown dimensions. What fascinating ideas did this young thinker share? How did scientists use these complex machines to create a doorway to a new dimension? Let's dig deeper into the story of this young genius who claims that some scientists, with the help of the Large Hadron Collider, managed to open a path to another dimension. Should we really take the ideas of a young mind seriously when it comes to such big mysteries? Maybe not. But what if this child understands the universe better than you might think? It's important to remember that the world is much bigger than what we see in our daily lives. Young minds can be powerful. The world is full of bright, young people doing extraordinary things. Think about Malala Yousafzai, who became a global symbol of courage and education. At only 21, Elizabeth Nance was already working at Johns Hopkins on tiny particles designed to move through brain tissue. Genius isn't limited by age, and sometimes the biggest ideas come from the youngest thinkers. Another example is Max Laughlin, whose thoughts on the Large Hadron Collider have sparked curiosity around the world. A child prodigy, Max is known for his engaging explanations of how the universe works and how humanity responds to each new discovery. But he didn't just share interesting facts, he also gave warnings. In his videos, he talks about how scientists at CERN may have opened a door to another dimension. But this wasn't the only amazing thing about him. At just 13, he invented a machine that could tap into free energy. He demonstrated his invention, explaining how it could change lives worldwide. Since then, he's gained attention for his sharp insights into the mysteries of our universe. One of his boldest ideas is that CERN's experiments could be causing small changes in our universe, possibly pushing us into a reality much like our own, but slightly different. The claim remains uncontested, as it is not the first time scientists at the European Organization for Nuclear Research, CERN, have conducted similar experiments. The Large Hadron Collider, a machine designed to break apart subatomic particles, is the primary tool used in these scientific efforts. This machine is also intended to recreate conditions similar to the Big Bang. It has been suggested that the actions of the collider may have damaged the structure of the universe, forcing humanity into an alternate dimension. Max Laughlin elaborated on the concept, explaining that the multiverse consists of an infinite number of parallel universes, and within each of these universes, individuals are constantly being thrust into different dimensions. Max described how, initially, humanity was on a single timeline, but when an unexpected event occurred during one of the experiments, people were thrown into an infinite number of other universes. At every moment, reality continues to shift, moving into a different universe. This endless series of universes is what humans now perceive as their present reality. It is likely that scientists at CERN became aware of this disruption in the fabric of space and time, intervening to correct the situation when they realized the irregularity. Their intervention confirmed that reality is far more complex than conventional understanding suggests. This explanation supports claims that CERN has been experimenting with the creation of gateways and altering connections across the universe. He continued his argument by proposing that CERN's ability to open these gateways indicates the presence of numerous parallel universes, connecting this idea to the Mandela effect. He further suggested that the particle accelerator may have altered a single electron, causing a fracture in known reality and transporting humanity to a different dimension. According to Max, it was the Large Hadron Collider that triggered this shift, pushing humanity into a new dimension. The Large Hadron Collider, LHC, is an impressive tool in the world of particle physics, created by the European Organization for Nuclear Research, CERN. Since it started working in 2008, the LHC has been the biggest and most powerful particle collider on Earth. It's located in a tunnel that stretches for about 27 kilometers, and it goes as deep as 175 meters underground, near Geneva, right on the border between France and Switzerland. The main job of the LHC is to speed up two particle beams in opposite directions, getting them close to the speed of light. It does this using superconducting magnets. When these beams collide at 4 specific points around the ring, special detectors are there to capture what happens next. This setup helps scientists dig deeper into how the universe works, testing different ideas in particle physics. Some of the most exciting things they study include the Higgs boson and the mysterious dark matter and energy. Next, we'll see how the scientific community responds to Max's theories and whether his youthful insights gain broader acceptance. The discovery of the Higgs boson. In 2012, scientists made an important discovery at the Large Hadron Collider, LHC. They found the Higgs boson. This was a big deal because it proved the existence of something called the Higgs field, which helps give mass to elementary particles. The discovery supported a major theory in physics, the Standard Model, which explains how particles and forces interact. The Higgs boson itself is special because it doesn't have a spin, no electric charge, and it disappears very quickly after it's created in high-energy collisions. Finding the Higgs boson wasn't easy. It doesn't stick around long and only shows up in about 1 out of every billion collisions at the LHC. Scientists had to look for the particles it breaks down into, like 2 photons or 4 muons, to spot it. These signs were the key to identifying the Higgs boson among all the other particles created during the collisions. Since this big discovery, experiments at the LHC have been all about learning more about the Higgs boson, especially how it interacts with other particles and how it decays. So far, the Higgs has been acting just like scientists expected, according to the Standard Model. This has helped us understand more about the forces that control the universe, including the weak force, which is super important in things like the reactions that happen inside the sun. But the story doesn't end here. Scientists think there's still a lot more to discover. Some theories suggest that there could be more than one kind of Higgs boson, or even new particles that we haven't found yet. These could help explain mysteries like dark matter, which is something we know exists but can't yet see or fully understand. Understanding the Higgs boson better is still a big goal for scientists working at the LHC. Every experiment helps them dig deeper into the laws of the universe and could lead to even more discoveries about how everything works. But this is just the beginning of what could be a much bigger story. But that's not all. The LHC also does experiments where it crashes lead ions together. This recreates conditions similar to the moments right after the Big Bang, allowing researchers to study the kinds of matter that existed in the early universe, like quark-gluon plasma. With regular upgrades and maintenance, the LHC keeps pushing the limits of science. In fact, an upcoming upgrade will allow even more collisions, increasing the chances of discovering new insights into physics. The detectors used in the Large Hadron Collider, LHC, are designed to observe different kinds of particles and events, playing a key role in the LHC's discoveries. They provide important data that help us better understand the universe. Aside from Laughlin's theory, the Large Hadron Collider has been considered potentially dangerous since the 1990s, during Bill Clinton's presidency. When the collider was still in its planning stages, many experts feared it could create a black hole that might consume the planet. These concerns prompted Francesco Calogero, a nuclear physicist from the University of Rome and a co-recipient of the Nobel Peace Prize in 1995, to publish an article in 2000 titled, "Might a Laboratory Experiment Destroy Planet Earth?" The essay sparked a long-running debate that lasted for many years. People argued over whether the Large Hadron Collider, LHC, could cause the end of the world. This discussion became widespread and even reached John Oliver's Daily Show in 2009. In one episode, John Oliver interviewed a physics professor who claimed there was a 50-50 chance that the LHC could create a black hole strong enough to destroy the Earth. To clear things up, John Oliver also talked to scientists from CERN, who were working on the LHC project. These experts firmly denied the professor's claims, explaining that the collider was built for scientific research, not to bring about an apocalypse. In another part of the discussion, Max talked about the Mandela effect, stating that he believed it was real. The Mandela effect refers to a strange occurrence where many people remember an event that never actually took place, which ties into a theory called the little geniuses theory. The Mandela effect, named by Fiona Broom in 2009, describes a situation where a group of people remember something that didn't happen or recall it differently from how it actually occurred. Broom identified this after she and others mistakenly remembered Nelson Mandela passing away in prison during the 1980s. In reality, Mandela died in 2013. She found it surprising that many people shared these detailed but incorrect memories, such as a widow's speech and city riots following his death. This phenomenon isn't limited to Mandela's death. It also includes misremembered lines from movies or confusion about logos and cartoon characters. For instance, many people think Darth Vader said, "Luke, I am your father," in Star Wars, which is not the correct line. Similarly, some remember Curious George having a tail, even though he never did. Other examples include people thinking Oscar Mayer is spelled differently or being confused about New Zealand's position compared to Australia. Psychologists suggest that these shared false memories may be linked to how our brains process information. One explanation is confabulation, where the brain fills in gaps in memory. Another idea is the misinformation effect, where memories change due to misleading information heard after an event. There's also priming, which means that earlier experiences shape how we remember things. These mental shortcuts, or biases, continue to be studied to better understand why they happen. The Mandela effect draws attention to the idea that human memory is more flexible than most people realize. It also highlights how collective social and cultural factors can influence what and how we remember events. As we continue our journey, the next chapter promises even greater discoveries in the cosmos. The ongoing hunt for dark matter. This shared memory matches with Max Laughlin's theory, which suggests that we might be living in an alternate version of our universe. Since the Large Hadron Collider started, it has been used to explore theoretical ideas in particle physics, especially those related to the Standard Model. The Standard Model explains most things in particle physics, but there are still some questions it doesn't answer. Since its completion in 2008, the LHC has gone through two major phases of operation. The first one lasted from 2010 to 2013, and the second one from 2015 to 2018. Each phase brought new discoveries and set records. However, questions about dark matter still remain. Most of what exists in space is invisible, but dark matter can be detected through its gravitational pull, acting like glue that holds galaxies together. The search for dark matter is one of the biggest challenges in science today, and the Large Hadron Collider was built partly to help solve this mystery. When it was first switched on in 2010, scientists were hopeful it would reveal new information. While it did lead to the discovery of the Higgs boson, no major breakthroughs have followed. Many had expected at least one new particle to provide clues about dark matter, but so far, no such particle has been found. Despite the massive effort and technology, dark matter remains elusive, keeping scientists searching for answers. The Large Hadron Collider, often called the LHC, was put on pause after its second round of experiments in 2018. This break was needed for big repairs and upgrades. After 3 long years of work, the LHC started up again on April 22, 2022. Shortly after, on July 5th, a new round of experiments began. This date was special because it was almost exactly 10 years since scientists discovered the Higgs boson particle. In January 2024, scientists at CERN made an important discovery of something called X particles. These particles were found in a special state of matter called quark-gluon plasma, which scientists believe is similar to the conditions right after the Big Bang. They made this discovery with the help of a machine learning algorithm, which was able to pick out the unique patterns of X particles from billions of other particles. This is impressive because the environment inside the Large Hadron Collider, where they were working, is extremely noisy, and these particles break apart into smaller pieces very quickly. The early data hints that X particles might be a type of tetraquark, which means they could be made up of 4 quarks bound tightly together. However, more research is needed to fully understand their exact structure. If this discovery holds up, it could help us learn much more about particle physics in the early universe. But that's not even the most surprising part. There's still a lot we don't know, and scientists are eager to explore more. Over time, these basic particles cooled and merged to create protons and neutrons, which are more common today. But, in rare cases, some of the quarks and gluons combined before cooling to make the short-lived X particle. Even now, scientists still don't fully understand how these basic particles interact to form X particles. Figuring out how these X particles are made and their structure could help scientists understand what types of particles existed during the universe's early days. To mimic those early conditions, scientists at CERN smashed lead atoms together at very high speeds. These collisions briefly recreated the hot, plasma-like state of the early universe. Scientists then had to sort through about 13 billion ion collisions to find the few X particles they were looking for. The LHC is set to keep running until 2025, after which it will be paused again for another 2 years of upgrades and improvements. CERN scientists are also hoping that future experiments with the collider will help them unlock the secrets of dark matter, one of the universe's greatest enigmas. Dark matter is a strange and invisible substance that makes up roughly 85% of the universe, yet we can't directly observe it using traditional methods or tools. While we know it exists due to its gravitational effects on visible matter, stars, and galaxies, its true nature remains elusive. By studying dark matter, scientists hope to gain insights not only into its composition but also into how it interacts with the rest of the cosmos. Understanding dark matter could hold the key to predicting how the universe will evolve, expand, and perhaps even reveal new dimensions of space and time that we've yet to comprehend. The more we learn, the closer we get to unraveling the vast mysteries that have puzzled astronomers and physicists for decades. What do you think about Max Laughlin's theory that CERN might have pushed humanity into a different dimension? Could our reality truly be altered by experiments in particle physics? Comment your thoughts below. And don't forget to like and subscribe for more thought-provoking discussions.